All right, so let's look at an example in which we are comparing the association between the amount of fat and the amount of calories in fast food hamburgers. So it looks like we've got a sample of 8 hamburgers. We've recorded their fat content and the calories, and now we've got two quantitative variables we can compare. So I've already created a scatter plot, and I let grams of fat be the explanatory variable and calories be the response variable. So you can do that. You can pause the video, take a second to do that. The first question we ask ourselves when we analyze this is whether or not the data appears to be linear, and it definitely does. It doesn't seem to be there. It doesn't seem to show any curve or any other type of relationship that would be better than a linear one. So I would say that this definitely indicates a linear association. So now we're asked to write the equation of the regression line. So to do that, you want to hit Stat, go over to Edit, and in L1 we're going to put 1931. I'm just going to go down the X list first. 34, 35, 39, 39, and 43. And over in L2, 410, 580, 590, 570, 640, 680, and 660. Okay, so now you've got the data there. As we've seen before, you're going to go to the quit screen, you're going to hit Stat, Calculate, Linear Regression, and when you compute it, you get this equation. You get y hat equals 11.05, let's say 11.06 x plus the y-intercept, which is 210,954. And there's our regression equation. Now, let me just remind you what these mean. This is predicted calories. So I'm going to put calories with a hat, and that equals 11.06 times the number of grams of fat plus 210.954. Okay, so that is our linear regression equation, and we can use it to make predictions about the number of calories given a particular amount of fat content. So this says interpret R in the context of the problem. You can see on the screen that R equals 0.961 about. And so what this would say, because this is so close to 1, we interpret this to mean there is a strong positive linear association between grams of fat and number of calories. Sorry, I'm running out of room here. Okay. Over here, we're asked to calculate the residual for a hamburger with 34 grams of fat. Okay, so remember that residual is equal to the actual minus the predicted. Okay, the actual amount of calories minus the predicted amount of calories for a hamburger that has 34 grams of fat. So if you look at the table, a hamburger with 34 grams of fat has 590 calories. Okay, now the predicted number of calories for a hamburger with 34 grams of fat. Well, that's something we need to use our linear regression equation for. So we just plug 34 in, and I'm gonna do that. I'm gonna indicate up here. Our predicted would be 11.06 times 34 plus 210.954. All right, and I mean our calculator could do, we could actually have our calculator store the equation, but we might as well just do it by hand here. So I'm just plugging this in. I'm getting 586.994. Okay, so if you do that and you do 590 minus that, you get 3.006. That's a difference in calories. Okay, so if we can see that actually that tells us that since the actual minus the predicted is a positive number, that means that we that our model under predicts for hamburgers, or in this in particular case, it under predicted for a hamburger that has 34 grams of fat. It under predicted the number of calories in such a hamburger. Okay, and the last thing we're going to do here is we're going to explain the meaning of the slope and the y-intercept. So the slope, if you go up and look at the slope there, it is 11.06. Now the units on that are number of calories per gram of fat. Okay, so what we would say is an additional gram of fat is associated with an additional 11.06 calories. Okay, according to our model. So our model basically tells us that in general, when it comes to hamburgers, each additional gram of fat generally is associated with an additional 11.06 calories. Okay, so if you're going to buy a hamburger that's 1 gram of fat, has 1 more gram of fat than another one, you should expect, according to our model, that you're going to intake 11.06 more calories. Okay, that's all it's saying. And lastly, the y-intercept. The y-intercept is 210.954. So let's restate that. So 0 grams of fat is associated with 210.954 calories. Okay, so again, I'm just interpreting the y-intercept in context. So basically, according to our model, if you come across a burger that has no fat, a fat-free burger, then you should expect that such a hamburger would have 210.954 calories, according to our model. All right. Now again, we only got sample of 8 hamburgers, so it's not that this isn't exactly what you expect to happen. It's just what our model's telling us. And of course, if you wanted to do a better job, you just get more data. Okay. But this problem kind of summarizes everything so far. We've looked at a scatter plot. We looked at checking to see that it's represents a linear association between two quantitative variables. We found the regression line, we calculated the correlation coefficient, we interpreted it, and we interpreted the line, the slope, and the y-intercept. So this kind of puts everything together. We even calculated a residual. So that wraps up linear regression.